A single fetch call looks simple, but behind it, the browser builds a full HTTP request, attaches headers, enforces security rules, and may even block the response entirely. So who actually handles all of this, JavaScript or the browser? Let's go inside and find out. Let's start with a simple idea. JavaScript itself cannot directly access the network, the file system, or device features. It cannot send HTTP requests, read files, or get your location on its own. So how does it do all of that? Through browser APIs. The browser provides built-in APIs that JavaScript can call to interact with the outside world. There are a few key categories. The DOM API lets JavaScript read and modify the page, adding elements, updating text, or handling events. The Fetch API lets JavaScript make network requests. File-related APIs, like FileReader or the File System Access API, allow reading files selected by the user. And WebSockets enable real-time communication. Here's the key idea. These APIs are not part of JavaScript itself. They are implemented by the browser and run outside the JavaScript engine. JavaScript simply calls them, and the browser handles the actual work. Now let's follow what happens when you call fetch. Your JavaScript code triggers the Fetch API. But instead of sending the request directly, it hands the task over to the browser's network layer. The browser then creates an HTTP request. This request includes not just the URL, but also additional information called headers. Headers provide context about the request. For example, the host header tells which server we are contacting. The authorization header may include authentication tokens. The content type header describes the format of the data being sent. And the user agent header identifies the browser and device. So a request is not just data. It is a structured message with metadata. Now let's understand how the browser decides whether a request is internal or external. It compares the request URL with the current page's origin. An origin is defined by three things: the protocol, the domain, and the port. If all three match, it is a same origin request. If any of them differ, it becomes a cross-origin request. For example, if your page is loaded from https://example.com and you make a request to https://api.example.com, this is considered a different origin. Now this introduces an important security rule. Browsers enforce something called the same origin policy. By default, JavaScript is not allowed to access responses from a different origin. To allow this, servers must enable CORS by sending specific response headers. For example, access control allow origin tells the browser which origins are allowed. If your origin is allowed, the browser lets JavaScript access the response. Otherwise, the response is blocked, even if the server sent it successfully. Now, in some cases, the browser performs an extra step before sending the actual request. This is called a preflight request. The browser sends an options request first to check if the server allows the real request. Only if the server approves, the actual request is sent. So even if the network request succeeds, the browser may still block JavaScript from accessing the data. Now let's look at the response. When the server responds, it also includes headers along with the data. These headers describe the response. For example, content type tells what kind of data is returned. Cache control tells the browser how long the response can be reused. Set cookie allows the server to store data in the browser. So communication between the browser and server is not just data exchange. It is a structured conversation using requests and responses, both carrying important metadata. And all of this is handled by the browser, not by JavaScript itself. So when you call an API from your code, you are not directly talking to the server. You are asking the browser to do it for you. And the browser manages the entire process, networking, security, and response handling. In the next video, we'll explore how browsers store data and manage processes internally. That's where things get even more interesting.